Romex, also known as non-metallic sheathed cable, has specific limitations when used with hard sealings. These limitations encompass size constraints, bundling rules, environmental factors, and physical protection requirements. First, consider the maximum bundle size. Romex can be bundled together, but the National Electrical Code, or NEC, specifies limits. For 14-gauge and 10-gauge Romex, a maximum bundle size is 12 current-carrying conductors. Exceeding this limit can lead to overheating and potential fire hazards. Secondly, consider the maximum conductor size. Romex is commonly used with 14-gauge, 12-gauge, or 10-gauge conductors. While larger sizes exist, they are less common in residential applications and may not be suitable for all hard sealing installations. Now, the conduit requirement. Romex cannot be used in metal conduit without additional protection. If running Romex through metal conduit, it must be protected with wire loom or non-metallic sheathing to prevent abrasion and potential short circuits. Proper staple spacing is critical. Romex must be stapled at least every 4.5 inches in walls and 12 inches in ceilings. This ensures the cable is properly supported and prevents sagging, which can lead to damage. Next is penetration of hard surfaces. Romex cannot be pierced or cut when passing through hard surfaces such as studs or joists. It must be protected with a hole saw or chisel to create a smooth opening that prevents abrasion. Damp or wet locations are an important consideration. Romex should not be used in damp or wet locations unless it is specifically rated for such conditions. Standard Romex is not designed to withstand moisture and can deteriorate quickly in such environments. Excessively high temperatures can also cause an issue. Romex is rated for operation at a maximum temperature of 90 degrees Celsius or 194 degrees Fahrenheit. It should not be exposed to temperatures beyond this limit, as this can degrade the insulation and create a fire hazard. On hard ceilings present challenging conditions, consider alternatives to Romex. One option is conduit and THHN wire. This provides greater protection for the conductors and allows for easier access to the wires for maintenance or upgrades. Individual THHN wires are run inside the conduit, offering superior protection compared to Romex. MC cable, or metal-clad cable, provides both physical and electrical protection for the conductors. The metal jacket safeguards the wires from damage and reduces the risk of fire. Another alternative is BX cable. This armored cable is flexible and easy to install in tight spaces. Its metallic armor provides a robust layer of protection against physical damage. When installing Romex, it's crucial to consider ampacity. Ampacity refers to the current carrying capacity of a conductor. The ampacity of Romex conductors is determined by the wire gauge and insulation type, as specified in the National Electrical Code, or NEC, Table 310.15b16. For example, 14-gauge Romex with type NMB insulation typically has an ampacity of 15 amps, while 12-gauge Romex has an ampacity of 20 amps. And 10-gauge Romex has an ampacity of 30 amps. Always consult the NEC for the most accurate and up-to-date ampacity ratings. Understanding voltage drop is also essential. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause appliances to malfunction and can even damage electrical equipment. To minimize voltage drop, use the correct wire gauge for the length of the circuit and the expected load. The National Electrical Code, or NEC, recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. When working with Romex, proper grounding is paramount for safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter, or GFCI, and preventing electrical shock. Romex typically includes a bare or green insulated grounding conductor. Ensure that all grounding connections are secure and made according to the National Electrical Code, or NEC, requirements in Section 250. Always use appropriate connectors and fittings when working with Romex. Connectors and fittings are used to join Romex to electrical boxes, devices, and other equipment. Use connectors that are specifically designed for Romex to ensure a secure and reliable connection. Avoid using damaged or corroded connectors, as they can compromise the integrity of the electrical system. Proper overcurrent protection is another crucial aspect of Romex installations. Overcurrent protection devices, such as circuit breakers and fuses, protect the wiring from excessive current, which can cause overheating and fires. Select the appropriate size overcurrent protection device based on the ampacity of the Romex conductors. For example, a 15 amp circuit breaker should be used with 14 gauge Romex, a 20 amp circuit breaker with 12 gauge Romex, and a 30 amp circuit breaker with 10 gauge Romex. Always follow the National Electrical Code, or NEC, guidelines for overcurrent protection. When installing Romex in hard ceilings, be mindful of fire stopping requirements. Fire stopping is the practice of sealing penetrations in fire-rated walls and ceilings to prevent the spread of fire and smoke. When Romex passes through a fire-rated ceiling, the opening around the cable must be sealed with a fire-rated sealant or caulk. This helps maintain the integrity of the fire barrier and prevents the rapid spread of fire. Always consult local building codes and the National Electrical Code, or NEC, for specific fire stopping requirements. Consider thermal insulation when installing Romex in insulated ceilings. When Romex is installed in ceilings with thermal insulation, the insulation can trap heat and cause the Romex to overheat. To prevent this, ensure that the Romex is not completely surrounded by insulation. Leave some space around the cable to allow for air circulation. Alternatively, use Romex that is specifically rated for use in insulated locations, such as Type NMB cable. Always follow the manufacturer's instructions and the National Electrical Code, or NEC, guidelines for installing Romex in insulated ceilings. Avoid using Romex in areas where it may be subject to physical damage. Romex is not designed to withstand heavy impacts or abrasion. In areas where the cable may be exposed to physical damage, such as unfinished basements or garages, consider using a more robust wiring method, such as metal conduit or armored cable. If Romex must be used in these areas, protect it with conduit or other physical barriers. Always prioritize safety when working with Romex. Before starting any electrical work, turn off the power to the circuit at the breaker panel. Use appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician. Always follow the National Electrical Code, or NEC, and local building codes to ensure a safe and compliant installation. Consider the type of hard sealing when choosing wiring method. Different types of hard ceilings, such as drywall, plaster, or concrete, may require different wiring techniques. For example, when running Romex through a drywall ceiling, use cable staples to secure the cable to the joists or framing members. When running Romex through a concrete ceiling, use concrete anchors to secure the cable to the ceiling. Always use the appropriate hardware and techniques for the type of ceiling you are working with. Be aware of the limitations of Romex in specific applications. Romex is not suitable for all applications. For example, Romex should not be used in underground installations or in direct burial applications. In these situations, use a wiring method that is specifically designed for those conditions, such as underground feeder or off cable or conduit with THWN conductors. Always consult the National Electrical Code, or NEC, and local building codes to ensure that you are using the appropriate wiring method for the application. Pay attention to the bend radius of Romex. The bend radius of Romex refers to the minimum radius that the cable can be bent without damaging the conductors or insulation. Bending Romex too sharply can cause the conductors to break or the insulation to crack, which can create a safety hazard. The National Electrical Code, or NEC, specifies the minimum bend radius for Romex in section 334.24. Always adhere to the specified bend radius when installing Romex. Consider the impact of electromagnetic interference, or EMI, on Romex. Electromagnetic interference can disrupt the performance of sensitive electronic equipment, such as audio and video systems. Romex is not shielded and can be susceptible to EMI. In areas where EMI is a concern, consider using a shielded wiring method such as metal conduit or armored cable. Always follow the manufacturer's instructions and the National Electrical Code, or NEC, guidelines for minimizing EMI. Be aware of the potential for rodent damage to Romex. Rodents can chew on Romex, damaging the insulation and exposing the conductors. This can create a fire hazard or electrical shock hazard. In areas where rodents are a problem, protect the Romex with conduit or other physical barriers. Consider using rodent-resistant Romex, which is specially designed to deter rodents. Always follow the National Electrical Code, or NEC, guidelines for protecting Romex from rodent damage. When working with Romex, always use the correct tools. Using the wrong tools can damage the cable or create unsafe conditions. Use cable strippers to remove the outer jacket of the Romex without damaging the conductors. Use cable staples to secure the cable to the framing members. Use a voltage tester to verify that the power is off before working on any electrical circuits. Always use tools that are in good condition and that are appropriate for the task at hand. Pay attention to the markings on Romex. Romex cables are marked with various information, such as the wire gauge, the number of conductors, the insulation type, and the manufacturer's name. These markings can help you identify the correct cable for the application and ensure that it is installed properly. The markings also indicate the cable's voltage and temperature ratings. Always read and understand the markings on Romex before installing it. Consider the color coding of Romex conductors. Romex conductors are color-coded to indicate their function. The black wire is typically the hot wire, the white wire is the neutral wire, and the bare or green wire is the grounding wire. Always follow the color code when making electrical connections. If you are unsure of the color code, consult the National Electrical Code, or NEC, or a qualified electrician. Be aware of the limitations of using Romex in high-voltage applications. Romex is typically used in residential and light commercial applications with voltages up to 600 volts. It is not suitable for high-voltage applications, such as those found in industrial settings. In high-voltage applications, use a wiring method that is specifically designed for those voltages, such as metal conduit with THHN conductors. Always consult the National Electrical Code, or NEC, and local building codes to ensure that you are using the appropriate wiring method for the application. Consider the use of arc fault circuit interrupters, or AFSIs, when using Romex. Arc fault circuit interrupters are devices that detect arc faults, which are dangerous electrical conditions that can cause fires. The National Electrical Code, or NEC, requires AFSIs in many circuits in residential buildings, including those that use Romex. AFSIs can provide an added layer of protection against electrical fires. Always follow the National Electrical Code, or NEC, guidelines for the use of AFSIs. Be aware of the potential for corrosion of Romex conductors. Romex conductors can corrode over time, especially in damp or humid environments. Corrosion can increase the resistance of the conductors, which can cause overheating and voltage drop. To prevent corrosion, use Romex that is specifically rated for use in damp or humid environments. Consider applying a corrosion-inhibiting compound to the conductors before making electrical connections. Always follow the National Electrical Code, or NEC, guidelines for preventing corrosion of electrical conductors. When installing Romex, ensure that it is properly supported. Romex should be supported at intervals of not more than 4.5 feet and within 12 inches of any electrical box or fitting. Proper support prevents the cable from sagging or becoming damaged. Use cable staples, cable ties, or other approved methods to support the cable. Always follow the National Electrical Code, or NEC, guidelines for supporting Romex. Be aware of the limitations of using Romex in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Romex is not suitable for use in hazardous locations. In these areas, use a wiring method that is specifically designed for hazardous locations, such as rigid metal conduit with explosion-proof fittings. Always consult the National Electrical Code, or NEC, and local building codes to ensure that you are using the appropriate wiring method for the application. Consider the use of surge protection devices, or SPDs, when using Romex. Surge protection devices protect electrical equipment from voltage surges, which can be caused by lightning strikes or other electrical disturbances. The National Electrical Code, or NEC, recommends the use of a SPD in many applications, including those that use Romex. SPD can help protect your valuable electrical equipment from damage. Always follow the National Electrical Code, or NEC, guidelines for the use of SPD. Be aware of the potential for electromagnetic fields, or EMFs, from Romex. Electromagnetic fields are invisible lines of force that surround electrical conductors. Some people are concerned about the potential health effects of EMF. To minimize exposure to EMF from Romex, keep the cable as far away as possible from living areas. Consider using shielded wiring methods, such as metal conduit or armored cable, which can reduce EMF emissions. Always follow the National Electrical Code, or NEC, guidelines for minimizing EMF exposure. When installing Romex, ensure that it is protected from physical damage. Romex should be protected from being crushed, cut, or abraded. Use conduit, raceways, or other protective measures to protect the cable from physical damage. Always follow the National Electrical Code, or NEC, guidelines for protecting Romex from physical damage. Be aware of the limitations of using Romex in plenum spaces. Plenum spaces are areas used for air handling, such as the space above a suspended ceiling. Romex is not suitable for use in plenum spaces unless it is specifically listed for that purpose. In plenum spaces, use a wiring method that is specifically designed for plenum applications, such as plenum-rated cable or metal conduit with THHN conductors. Always consult the National Electrical Code, or NEC, and local building codes to ensure that you are using the appropriate wiring method for the application. Consider the use of ground fault circuit interrupters, or GFCIs, when using Romex. Ground fault circuit interrupters are devices that detect ground faults, which are dangerous electrical conditions that can cause electrical shock. The National Electrical Code, or NEC, requires GFCIs in many circuits in residential buildings, including those that use Romex. GFCIs can provide an added layer of protection against electrical shock. Always follow the National Electrical Code, or NEC, guidelines for the use of GFCIs.